Ready to start section 2.7? We're going to continue on with functions. So in the last section, we learned how to identify functions from a set of ordered pairs, how to tell if a graph was a graph of a function. We learned a little bit about function values, function notation, evaluating functions. So we're basically just going to carry on with that in the second section. We're going to do a lot of graphing in this section. We're going to learn how to find x and y intercepts, and we're going to do some more function notation with the graphs. So we have m and b represent real numbers such that m is not 0. So f of x equals mx plus b is a linear function. So think back to this, y equals mx plus b. Remember how we learned that was a linear equation? Well, these are exactly the same thing. They just replace the word equation with function because now they're using f of x in place of y. Exact same thing, because students are like, oh, I don't know how to do functions. All you have to remember is f of x is really just y. So put a y in there and you're back to your familiar little equation we've been using. And if we have y equals k, notice how there's no x. K is called a constant, so let's just put a number in there. Y equals 3, let's say. We learned in previous sections, anytime an equation does not have both an x and a y, it's one of our special cases. So this means it only goes through the y-axis. It never passes through the x, and it goes through at 3. So if it only goes through the y-axis, that means that is a horizontal line. We call that a constant function. So if it only has an x, it's a vertical line. If it only has a y, it's a horizontal line. And because we know f of x is really y, it's a horizontal line that passes through whatever k is. In this case, I called k 3. Okay, so we're going to be graphing regular lines, y equals mx plus b, and horizontal lines. So some of you may be thinking, well, why aren't we graphing vertical lines? Well, vertical lines don't pass the vertical line test, because think how many times I would hit a vertical line if I passed a vertical line on top of it. So vertical lines are not functions. A regular line is a function because it passes the vertical line test. A horizontal line is a function because it passes the vertical line test. But vertical lines don't pass the vertical line test. They fail it. So this says graph. So we're going to use our techniques from, I can't remember what section it was. Maybe 1.8. It was 2 sections ago. 1.4. Can't remember the name of all of them because I skipped, but we learned how to graph lines and write equations of lines on our second day. So we're going to continue with that. So in my head, I change it to this, y equals 3x plus 2, because now I have a familiar problem. I know how to do this. We did a whole bunch of them when we were doing our notes. So we learned the first thing you're supposed to do is write the y-intercept. And remember, on the y-intercept, x is always 0. So 0, comma, and this was always our y-intercept, the constant at the end, the 2. Then the second thing we did was write down the slope, which is rise over run, to help us graph. So because it's a whole number, I do need to put it over 1. So the rise over run is 3 over 1. So now we're ready to graph that line. So because the slope's positive, when we put the line on it, remember it should be rising from left to right. So we have 0, 2, and then we're going to rise 1, 2, 3, and run 1. So notice how I ran out of graph. Remember how we learned to go backwards after we make that first dot? So rise 3, run 1. So what's the opposite? Go down 3 and back 1. So that gives us our third point. Because because usually on tests you are asked to make 3 points. And I've had students go, well, when they graph it, we run out of graph. Well, then you do the opposite. So rise 3, run 1. According to this, the opposite would be go down 3, go back 1. Then we use our straight edge to connect the line. And remember, don't forget the arrows on both ends. Lines go on indefinitely in both directions. So there is y equals 3x plus 2, or f of x equals 3x plus 2. So nothing different. Graph it exactly like you did back in the linear function section, or linear equations. Okay, this next one is the same thing as y equals -5. So the first thing I look at is I go, oh, there's no x in this problem. If there's no x, that means it's a special case. It's either horizontal or vertical, and this tells me it only passes through the y-axis. Well, the only kind of line that only passes through the y and never touches the x is horizontal. So if you wanted, you could write this, because do you agree they're the same thing? 0 times x is 0. So that means the slope is 0, and you're supposed to have memorized that anytime a line has a slope of 0, it's horizontal. So go down to y, put a dot at -5, and on Alex, they make you graph other points too. So you can just pick any other points you want on that horizontal line and just graph them. Because a lot of students, when they were doing that, said, well, I know how to get the first one. How do I get the others? Well, any point on that line works. So I just picked random points. And remember, I know it's horizontal because there's no x. There's only a y, which means it only passes through the y-axis, and that would make it horizontal. If it had been x equals -5, then it would have been a vertical line. Okay? But this is y equals -5. And there we have it. So 0 slope, slope 3/1. So when you get to 150, which is the next class, they make you memorize these. You have what's called a library of functions, and it has 10 functions on it, but this is 6 of them. So we're just going to go over them. I'm not going to make you memorize them. In this section, you know this one, and the rest of our textbook is going to concentrate on these. We call these parabolas. They're quadratic functions, which means they're second-degree functions. So all the other graphs on this page are actually in Math 150, but this is kind of a nice time, so I'm not going to make you memorize them, but this is a nice time to review domain and range. So domain remembers left to right. See how this graph goes left forever and right forever? So that's why the domain is -infinity to +infinity. The range is bottom to top. This graph goes down forever and up forever. That's why the range is -infinity to +infinity. Parabola goes left forever and right forever. That's why I'm so picky about students putting arrows on their graphs, because that's how you know to put your infinity. So left forever, right forever, because domain is left to right. And so again, we have -infinity to +infinity. The range, though, is not that. When we roll our pencil from bottom to top, we see the lowest y value is 0. But it's an actual point on the graph, so see the bracket, 0, and the highest y value, infinity. So this is really great practice if you struggle with domain and range, because they're already done and you can see them worked out here. So let's write our little reminder bottom to top there. So domain are the x's. We start with the left-hand x and we go to the right-hand x. Range are the y's. We start with the lowest y, we go to the highest y. And remember, when you look at your interval notation, the smallest number should be listed first the largest number second. And if you look, that's always true. Okay, next we have what's called a cubic, and that's a third degree equation. They make S-curves. So again, the arrows tell me this one goes left forever, this one goes right forever. So notice the domain again is negative infinity to positive infinity. Range is bottom to top. This graph goes down forever and it goes up forever. So both the domain and range of cubic functions, third degree equations, are negative infinity to positive. So it goes left forever, right forever, down forever, up forever. And then another one that you study in the next class is called the absolute value function. So again, left forever, right forever, so not surprising, that's the domain, but the range is going to be just like with the parabola, the second degree, when you roll from bottom to top, your lowest y value is 0, and then it goes up forever. So you put a bracket at 0 to show it starts at 0 and it's actually equal to 0, and then it goes up to infinity. Square root function, which we work on square roots in chapter 6 in this class, so we'll see more of this. So here's the starting point for the square root function. So when I'm going left to right to find my domain, I see my first x value is 0, and it's an actual point, and then it goes right forever. So it starts as 0 with a bracket, and then it goes right forever to infinity. And when I go bottom to top for the range, my lowest y is also 0 with a bracket, and this is just going to keep going up gradually, up, 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 up. So it's going to go to infinity too. So same domain and range for the square root function. And then last we have what's called the reciprocal function, because this is the reciprocal of x, right? This is one of those tricky ones like we had on the last one with the u in it, because see how the graph has stops and starts again? So first you have to give this domain, then you do a u, and then you give this domain, then you have to do this range, then you do a u to join it with this range. So there's two separate domains, one for the left, one for the right, and two separate ranges, one for the bottom, one for the top. So on the domain, we go left to right. So I can see this is negative infinity because it goes left forever. And then it travels up to 0, but never touches 0. See how it slides right along beside the y-axis? So look at the 0 with a parenthesis. And then we unite it with this domain that picks up at 0, but never hits 0 again, and goes all the way right forever, which is infinity. So students go, why can't you just write negative infinity to positive infinity? Because 0 isn't part of the domain. So we have to stop it at 0 and start it up on the other side of 0. And that's why we have the parentheses to show 0 is not included. And then the range is the same thing. Going bottom to top, you can see the lowest y value is negative infinity. And it goes up to 0, but never touches 0. So we put 0 with a parenthesis, and then we have to unite it with this range, bottom to top. So this starts right above 0. So 0 with a parenthesis and goes up forever to infinity. So you're probably thinking, how do we know how to draw these graphs? Well, we should have, and in 150 you do have to do this, you kind of memorize the basic shape. So I know when there's no exponent, when it's y equals mx plus b, it's going to be a line. I know when it has a exponent of 2, it's as the highest power, it's going to be a parabola. I know when it's an exponent of 3 as the highest power, it's going to be an S-curve. So we memorize those basic functions, and that helps us draw the graph. But we do make t-tables for these so that we can kind of get the general idea. So we memorize the shapes, and then we do t-tables to get the actual points. Okay? But these are the two you're going to be responsible for in this class. These other ones you don't have to memorize in this class, but you will in the next. Okay, so we are at the end of the video, so we'll start the next page on the next video.